Welcome to qnawire.
So we have a planet that has a radius of 3.24 times 10 to the 6 meters, and we know that the escape velocity on that planet is 7.65 times 10 to the third meters per second. And ultimately, we want to find what the acceleration due to gravity on that planet is. So to start, we know that the acceleration for gravity on any planet should be gravitational constant times the mass of the planet times the radius squared. So we know the gravitational constant and we're given the radius. So the only thing we don't have here is the mass. So hopefully then using this information we'll define what the mass of the planet is. So let's think about the escape velocity. We know that the escape velocity for a planet should be the square root of 2 times the gravitational constant times the mass of the planet over the radius of the planet. So it looks like we could solve for the mass of the planet here. So we'll square both sides. So v squared equals 2gm over r. And then we can solve for the mass, and that should be v squared r over 2g. So now we have the mass in terms of things that we know. We know the escape velocity, we know the radius, we know the gravitational acceleration, and we know the value of 2. So we can now just plug that in over here. And so we have g over r squared, and then times v squared times r over 2g. So these g's cancel out. So this constant doesn't actually matter here. The acceleration would be the same regardless. And this radius cancels out, and then we lose that square in the denominator. So this simplifies a lot then, and we just get that it should be v squared, the escape velocity, over 2 times the radius of the planet. And so those are the two values that we're given now. And so we can evaluate this, and we get that it's 9.03 meters per second squared.